My name is Pete Whitney. I'm a solutions architect with GridGain Systems. I'm excited to speak with you today about the concepts of affinity and data co-location. With that, let's get started. Affinity and data co-location are similar concepts. Affinity is a term that refers to one table and allows data in that table to be pre-grouped based on one or more columns of that table. By pre-grouping, I mean that rows that have the same column value will be stored on one host and not distributed to many hosts. Data co-location refers to two or more tables that are frequently joined on a specific column. To support efficient join operations, all join tables use a common affinity key or column. This forces the Apache Ignite system to locate records with specific column values on the same hosts. In doing so, the system will not have to send join records over the network to accomplish the join operation. The net effect is improved join performance due to data co-locality. We have an example data set. The data set is the New York taxi trip data that is publicly available on the internet. The data set has many columns, but for our business purposes, we'll only execute some basic driver analysis. We will do this on one table called NYC Taxi that does not use the benefits of Affinity. We've also stored the very same 7 million records in a second data set named NYC Taxi Affinity. The Affinity data set is stored using the driver ID field as its affinity key. This will allow us to perform basic business driver-based analyses to realize the benefits of performance benefits of data stored using the affinity key. Here's a look at the two table creation statements. We can see our first table, NYC Taxi, has a primary key called PK. That happens to be a UUID field. And we can see that there's no affinity key statement in this. This data, as it's loaded, is going to be distributed across the system randomly using this, or rather randomly. One caveat that is not random is each data, or each host, will get approximately the same number of records, but there's nothing about a UUID that allows us any analysis benefit to leverage as we analyze this data. Our next data set, the NYC Taxi Affinity data set, is the very same data set. It has the same primary key. It is actually a copy of the first data set. The only difference is this primary key adds the driver ID, and we're telling the system, instructing the system, that this affinity key is the driver ID. When the system loads this data, all records that have the same value of driver ID will be located on the same host. So with that as background, we can see that both tables have the same number of records. Let's take a look at that. We'll execute a count here against our NYC Taxi table. And we see that we have approximately 7 million rows, 7,019,375. What about our affinity data set? Same number of rows, 7,019,375. Okay. I can share with you that each of these data sets have exactly 9,000 distinct driver IDs. But to get an understanding of how those driver IDs are distributed around the system, let's randomly select one of these driver IDs, driver 3001, okay? We're going to take a look and we're going to find out that this driver has about 780 records. Now that query was executed against all hosts. So on all three hosts, there's 780 records that have a driver ID of 3001. But what happens if we just select one of the nodes? Well, for our system that doesn't use Affinity, it's thinking I want to execute just that portion of the statement. Sorry about that. Now we're querying just one node, and we can see that that node has 252 records. What about our second data node? $271. And finally, for our third one, $257. You add that up, you'll get 780. Okay. What about our Affinity? Our Affinity data set. Nope, that's not the right query. There it is. So I'm going to execute that against the entire cluster. Oh, cancel. We're not going to select a node. We can see that we have the same 780, but things get a little different now. Instead of about 200 records on each node, we're going to find that that host doesn't have any records for that data, for that driver ID. What about the second host? Once again, well, if I was a betting man, I would say that this third host is going to have 780. And lo and behold, it does. So what we can see is that for this particular driver, the system chose the third node to be, for it to be the host to hold all the records for driver ID 3001. Now you'll find that there are, in fact, other driver IDs on the other three hosts, and those will be distributed approximately evenly. So we should expect to see approximately 3,000 driver IDs on one host with the Affinity data set, 3,000 driver IDs on the on the second host, and approximately 3,000 on the third host. It won't be perfectly 3,000, but that rough grouping certainly gives us performance improvements that we can leverage in our business analysis. Well, with that in mind, let's do some business analysis. If we were to select, I wonder, what is our max driver distance or maximum distance that our drivers have driven? We'll execute this query on the NYC taxi data set, and I'm not going to make that same mistake by making a selection. I'll execute that. And this is running on all nodes on the cluster. So it's trying to find the maximum driver, the driver ID, and the maximum distance for each driver ID. And just a point of curiosity. So here's people that have taken long trips. I'm actually executing this just to get some query timings. We'll look at those in a little bit. Okay. We're going to do the same thing, but this time we'll do it on our NYC taxi Affinity data set. We'll execute that query. Once again, I'm really just driving the system to get some timings. We get the same answers. Yep. And we get our distances for that. Let's do one more business analysis before we take a look at the performance improvement that we get out of those. Okay. What about total revenue? And I've also added average trip distance just out of curiosity. This will go against our NYC taxi data set, which does not have Affinity or is not stored using Affinity is probably a better way to term that. And we get our 10 records, and it shows our total revenue. By the way, this data set happens to be for 1 month. So in 1 month, these drivers produce this much revenue. Somewhat interesting correlation, potentially, something to investigate for your business. It seems as though revenue increases as trip distance decreases. Might see what I can do with my business to leverage that correlation, if in fact it does hold true for a larger data set. Okay. Same thing here, but this one is against our NYC taxi Affinity data set. And once again, we get our same answers and the same co-location, or I'm sorry, the same correlation on average distance. Now let's take a look at our query statistics. Okay, so here's the most recent. I've sorted on the last start. So here's our most recent queries. We can take a look. Say this happens to be our Affinity data set, and that executed in 5 seconds. This was the same query against our NYC taxi data set, and that executed in 7 seconds. Similar for max distance on Affinity, we get 3 seconds, and max distance on NYC Taxi, we get 5 seconds. So leveraging Affinity in both of these data sets improved the performance of the same query by 2 seconds for each of those executions. And you might say, well, 2 seconds, do I really care about 2 seconds? Well, really would like you to consider that if there was a 5-second query and you were to execute that once every 5 seconds, you would have, 5 seconds drop down to 3 seconds represents a 40% improvement. But when you think about it in terms of what did I save over the course of the day, the numbers can actually be quite interesting in that you would, for a 5-second job, you can execute that 17,280 times in a day, and that 2-second improvement would return back or give back over 34,000 seconds of execution time. That's 576 minutes or 9.6 hours. So that's 9.6 hours of execution time that your cluster is more efficient and able to serve you, getting more business value out of the data that you've already put onto the cluster. So the performance difference is quite nice. And there's a similar story with data co-location. As I said earlier, data co-location refers to the performance improvement that you get by co-locating records that will be joined on the same affinity key. And the performance benefit comes from when the system executes that join, the data does not have to be sent over the network to produce the join. It provides wonderful, although I didn't demonstrate data co-locality here, it certainly is something that you should take a look at for tables that you join often, if they have that common key, and that key ends up being a nice distributing factor for your data sets, you can make wonderful things happen on your cluster. And, you know, even from a financial perspective, if you can get the same job done with fewer nodes or not have to grow your cluster because your cluster is efficient enough to handle your workload, you've delivered value to your business and your operations. That's the end of my talk. I hope you've enjoyed it, learned a little bit about Affinity and data co-location. And at that point, I'd like to open it up for questions.
Thank you, Peter. I'm going to invite you back on the stage with me again. We do have a question for you. And the question is this: how does Ignite prevent certain nodes containing hot data or more records from becoming a bottleneck in operation?
So Ignite will tend to distribute all data approximately uniformly over a cluster based on a hash of the primary key. That means that two records that come in, they have to have differences in the primary key. That means that some of those new data elements are going to go to one host, some of them will go to another host. And as a result of that, let's say random distribution of new data among the many nodes, the workload associated with hot data also gets distributed. So we're distributing the data, and as a result, you're distributing the workload.
Good.
And it's interesting. There was a question in another talk that asked about shouldn't I be able to partition based by date? And if you were to do that, the effect of that would be today's data would all go on one host. So what do people work on? Most businesses, they're usually working on today's data, which means that data is good. You're going to swamp one host with all of today's data if you were to partition by date instead of distributing that out. Now, if your work is an analysis work where you need to group those records or join those records, This is where Affinity will join these records together, but not necessarily new records, right? It's only records with the same affinity key that will go on the same host, but still new records will still be distributed across many hosts. So the work is distributed wide, but the data can still be co-located. So that you can join both of these capabilities and not have to worry about hotspots or hot data overloading one host.
Excellent. It's a good answer. So a lot of that comes down to being clever about how you choose the right affinity key.
Yeah, and another great example, even just to go back to that one question, because I know that date type partitioning is such a common thing. If you figure out the size of your cluster based on the amount of data that you have in a time span, you can throw away any need for date-based partitioning, because now your new records, your new data sets can come into the cluster. And if you're using a TTL, the older records would basically age out as the new ones come in. Instead of doing, and long story short is, instead of doing it by time, do it by size.
Right, great. Well, there's a question coming through in the chat from Swapnil. If you want to have a go at answering this.
I love this question. Oh, go ahead. Yeah.
So typical data lakes have dimension data, OLTP, OLAP, or BL, and BI at least, and how to put this huge data on Ignite via key partitions or affinity. This is a typical use case of batching jobs.
Sure. Well, so in Ignite, hopefully you're sizing the cluster to support your data set. So in other words, if you're using Ignite for its sweet spot, which I consider to be, don't have two systems, just have one, use Ignite for your OLTP work as well as your analytic work, then you don't have to worry about batching and data transfers or any of that thing. Now, to be fair, memory, there is a cost to that. And then the key is sizing a cluster to the correct size, which typically means number of nodes, to be able to accommodate the data size you need for your OLTP in analytics work that you're doing.
Great. Okay. And one final question from Sasikumar. For instance, if we concentrate a particular key on one host, what happens if that node fails? Will Affinity help in the failover?
So all systems that, if you need the reliability of the data, then in other words, if that is a key part of your business use case, and it is for many business use cases, is your cache should have a backup. And what Ignite will do with a backup is, when a new record arrives, it will store it in its primary cache or primary partition. The partition will be chosen for that record, and that partition will have a backup that is on another host. So if your primary host fails, then the system will have a backup of that partition, because all partitions will be backed up, but they're never backed up on the same node. So that's how the system delivers reliability through redundancy. And you can choose the number of backups. You can choose one backup or two or three, whatever your needs are. Now, of course, if you're doing one backup, that's twice the size of whatever your cache is. So it's always a cost or versus needs discussion.
Thank you. All right. Well, that really is all that we have time for. And actually, that draws us to the close. So, Pete, I'm going to thank you for joining me on the stage,
Thank you.
and look forward to you contributing to future summits.